Okay, so I'm starting the recording, and we've obviously done a little bit of work already. We were just talking out loud about this made-up scenario where we were going to sell a fourth period class calendar. But now we're starting our first example. We are solving systems of equations, and our first example will be solved by graphing. The first equation was x plus y equals 3. Yes, ma'am. The second equation is going to be negative 2x plus y equals negative 6. If we're going to solve by graphing, what will I have to do to these equations? Do it. Get y by itself. Just draw an arrow out to the side and rewrite each of those with y isolated. Hey, Ben, you have to take that off. First equation, Caitlin, what will that look like when you isolate y?
Y equals negative x plus 3.
Excellent job with your sign. Good job. Make sure your signs are right. That needs to go in your backpack. Zipped up, please. Troy, what will that second equation look like, isolated? Beautiful. All right, guys. In a minute, I'm going to give you some Miss Olson graph paper, but for these first couple, you're going to need a sheet of regular graph paper. Take out some graph paper from your binder, please. Miss Olson graph paper is fantastic when the numbers are really small, but when you start talking about these real-life scenarios, sometimes they're larger, and you're going to need a full sheet. I'll show you what we're going to do with this. All right, go to the top of your graph paper and put, who doesn't have graph paper in their binder? Who's going to have graph paper in their binder tomorrow? Do better, people. Go to the top right corner and put today's date so you can match it up with your paper notes. Come over here to the top left corner and write example 1 to match the example 1 on your notes. All right, let's talk about this. Look at my y-intercepts. I'm going to have to go a y-intercept up to 3 and down to 6. So I need a pretty significant y-axis, don't I? Bigger than what we would get on this Olson graph paper. So I'm going to zoom this out so you can see my whole page. I'm going to leave myself some room over here and draw my y-axis pretty long. Like, count where I have at least about 10 or so above and about 10 below. Make myself a pretty good y-axis, and then come in and draw your x-axis. Put your arrows on the ends. Precision is really important today with what we're trying to accomplish here. All right, let's graph that first equation together. Y equals negative x plus 3. Where do I start? On 3 on what axis? Y-axis, right up here. What is my slope going to be? Where do you find the slope? It's negative 1, isn't it? So that means negative 1 over 1. Down 1, rise negative 1, run positive 1. Rise negative, run positive. Do that all the way to the edge of the graph. I want to see points, 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 all the way to the edge of the graph. Make points all the way to the edge. Do not sketch a line. Points. Now go back up to here, and you can rise 1 and run negative 1. And then give me points all the way to the edge of the graph. Only when you have an entire series of points do I want you to draw the line and connect it. With today's lesson, if you get even off a little bit, you're not going to be able to answer the question at the end. So draw that line carefully. Stay within the points. Edge to edge. You don't know where the answer is going to be, so all the way from edge to edge. Let's do the second one. Y equals 2x minus 6. Where do we start? 2, 4, 6. Slope? Slope is rise 2, run 1. Rise 2, run 1. Follow it and make all the points. All the way to the edge. And rise -2, run -1. Once you've got points all the way to the edge, go connect those. I want to see your points. I want to see how precise you're being. Draw that line before you start this one so you don't lose your points and get confused. Very nice. Very nice. Good. 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 Okay, draw the first line before you start the second one so you don't get confused with your points. Draw one line and then draw the second one. Good. Nice. Nice points, guys. Every point on this line is a solution to that equation, isn't it? Every single point on this line is a solution to that equation. Every single point on this line is a solution to that equation. Do you agree? In other words, look, you see this weird point right here? You see that right there between my fingernails? That unnameable, that weird point right there, that is a solution to this equation, isn't it? And whatever that is, maybe it's like 5.2, 6.1, whatever it is, that is a solution. Everything is a solution. But here's my question. What is the only point that is a solution for both of them? Where it crosses. Do you see it right there? That is the only point that is a solution for this equation and this equation. Can you name that point right there?
3-0.
3-0. Come over here to your lined paper. The solution to this equation is 3-0. That is the only point that is true for both of them because it's the point where they cross. What does that mean that it's the solution for both of them? Take 3-0 and plug it in right here. If I plug a 3 in right there, I have -3 plus 3 equals 0. And if I plug it into this one, look what happens. 2 times 3 is 6, minus 6 is 0. Those 2 points, that point right there, works for both of them. You getting the idea here? That's what we're doing. We're looking for solutions that work for both of them. And we're doing it by graphing. Excellent. Let's do another one. Example 2, right with me. -8x plus 2y equals 20. And the second equation, -4x plus y equals 12. Wait, not 12. Equals 3. Equals 3. All right. What do we need to do first? Get y by itself. Go for it. Did you do that right? That top one right? Good job. All right, and how about this one? This one's probably easier. Y equals 4x plus 3. Great. Go back to your graph paper. You have all this big space over here. Let's make another coordinate plane down here, and let's graph our 2 equations. We got a lot of big positive numbers, so I'm going to make that y-axis really long again. Put your x-axis. And graph them. Where do we start?
You'll start at 10.
And go up 4 over 1. That's not going to go very high, is it? 1, 2, 3, 4, before we run out of room. So what do? Go back the other way. Yeah, do the other way. -4, -1. Don't forget to make points. Do not just sketch it. Do we have to worry about dashed line or solid line on these? Why not? That's only inequalities. Very good. Yeah, on inequalities, we have to worry about dashed and solid. These are all solid. Draw them. And your second equation, go ahead and graph it. Yeah. Oh. Did you get your two equations right? The top one wasn't right? Really? What'd you do on the second one? What went wrong?
I think it was when I had got to 2y equals 18x plus 20.
Oh, it's not 18. It's just 8. Wrote the problem down wrong. Okay, go ahead and graph that second one. What are you finding, guys?
That is parallel.
What does that mean?
They don't cross.
No solution? They're never ever going to cross each other? Even if it extends forever, will it ever cross each other if they're parallel?
No.
It never will. They never get any closer or any farther apart, do they? So what do we say? We say, no, not 0, 0, because that would mean it crosses right there. We say null set or no solution, either one. Good. No solution, null set, the zero with the line through it. Very nice. Very nice. How could we have known this from right here, that these two were not going to, that they were parallel? We learned that last week, didn't we? That when the slopes are the same, they're parallel. So we could have seen right from there that there was going to be no solution. Awesome. Okay, I want to show you a tool on your computer. Take out your computer real quickly. Have any of you never heard of Desmos.com? If you've been in my class before, you've seen it because I've showed it to you before. Okay? Go to Desmos.com. That's DESMOS.com. DESMOS. Desmos.com. Whew. That was not what I meant to do. DESMOS.com, and you should come up on that page with the blue on it. Looks like this. Let's learn together. Everybody see that? And click on Graphing Calculator. I want to show you, there's some things you can do on this that I just think are a little bit more navigable than doing it on our calculator. We're going to do these on our calculator later, but right now I wanted to do it on here to show you some things. When we're talking about big numbers, Desmos is kind of cool because you can zoom so easily, okay? So let's go back to that calendar thing for a minute, because I just left that, didn't I? I want to talk about a break-even point, the point where your income and your expenses meet, and once you cross that point, your income becomes profit. You see what I'm saying? The first 5 or 10 calendars we sell, we have not made any money, right? Because of our design fee and our paper. You're not if you're with me. You see what I'm saying? The break-even point is where they cross. So let's do this together real quickly. Take that first equation, y equals 15x, come over here to beside the 1, and type in y equals 15x. All right, we've got this pretty steep line here for profit. It looks like the profit's going up pretty fast. Might want to zoom it out just a little bit so that you can kind of see. You can grab the middle and move it over. That's kind of showing our profit, how our money's how we're going to be making money. You with me? Now let's type another equation for our expenses, our expenditures. Come underneath that 1, that red, and let's type in that second equation. Do you see it? What was it? Y equals 3x. Was that it? Plus 100. Type in your y equals 3x plus 100. That blue line is telling us where our expenses are. If I zoom back in a little bit and look at this right here, when I have sold, let's see, this is 5, 10, 15, 20. When I've sold 5 calendars, I am still below my expenses, aren't I? My expenses are higher than my income. You following what I'm saying? At what point do my expenses and my income meet? Do it on yours. Look at it on yours. Where do the expenses and the income meet?
At 8.3 repeating and 125.
Okay, you can touch it right there. 125, that's standing for what? 125. What is the y-axis? What did y stand for again in our problem? Look at your paper. The dollars, right? Y is the dollars. The dollars you spend, the dollars you make. So over here, my y-axis, at $125, I start breaking even. At 8.33, what is that x value representing again? Calendars. That means all I had to do was sell 8.3, or let's say 9 calendars before I started making money. Now look up here. As the number of calendars goes up, our money we're making is going to be higher than what we spent, right? So everything above the break-even point is profit. Can you see why that would be necessary for a business to understand that and be able to figure out a bakery, be able to figure out when their cost for ingredients is going to be surpassed by their profit in selling brownies? Do you see the importance there? Mm-hmm. Yes, do you really? Mm-hmm. Not really thinking about it? Have you ever thought of wanting to sell something?
Yeah.
I mean, let's think about somebody who's doing candy. Okay, if you're wanting to sell candy, well, first you have to purchase that product, don't you? You have to go to Sam's. When we saved up money for the Washington trip, and we did nacho sales and crazy stuff like that. You have to go to Sam's and purchase the candy or purchase the chips and the cheese, and you have spent money. You're in the hole right then. Until you start selling the candy and you begin making money. And at some point, you've sold enough candy bars that you have made back everything you spent at Sam's, and everything further is profit. Make sense? I spent $40 on candy bars. I'm selling them for $2 a piece. The first 20, I haven't made any money. I'm just recouping what I spent. But once I sell 21, now I'm making profit. After that, every candy bar after that is profit. All right. I just wanted us to go over that one together and let you see Desmos. Back on your paper. Right now, we're going to work from page, hang on, let me get it right here. Page 48. And I'm going to hand you a sheet of Miss Olson graph paper to work this. And on page 48, I'm wanting you to do, I've really been struggling with figuring out which ones I wanted you to do, so give me just a second to get this right. I want you to do numbers 32, 33, 35, and 40. 32, 33, 35, and 40. Not P48, page 48.
Well, you put P.
I'm sorry. I once I get past these beginning pages, I can start putting P. Forgive me, it's page 48.
Yes,
I'll go to right. Come on. Thank you. You're welcome. Let me get one more for you, Trey.
No, I'm not.
Yes, I'm snitching.
That's all I need to do.
Speak life, don't be ugly.
Yeah, you're right.
32, 33, 35, and 40. You've got 4 blanks right there. Put your name, put the date, and get started. Make sure you rearrange each one carefully first.